In this ClimateGenn episode, Professor of Climate Risk at the University of Newcastle, Hayley Fowler, and Professor Paul Davies, Chief Meteorologist at the UK Met Office, explain how the mega storm events we are now seeing so frequently are generated and why they are going to get more intense and more widespread. This was recorded just after the incredible Central European flooding in the first half of September. Since then, the media has been filled with images of Hurricane Milton, and now we see the area around Valencia of Spain is lying in ruins. With the UN Climate Summit only days away, we are witnessing a decisive US election where one of the nominees denies we have an existential climate problem in favour of taking money from the fossil fuel industry and enacting policies that amplify the impacts. Will COP29 be another washout like COP22 in Morocco in 2016? Only time will tell. I will be reporting from the COP, publishing a range of interviews across key topics. The collaboration between senior climate scientist Hayley Fowler and chief meteorologist Paul Davies is increasing our understanding of extremes, so that we can be better prepared in the face of these life-threatening storms. A link to their recent research paper on this topic is in the notes. As both scientists warn, new technology such as warning systems can help us save lives, but it will not cure the problem. We urgently need global emissions reductions at rates of around 43% by 2030 to avoid the very worst of a wide range of impacts. It is obviously too late to avert a new era of climate disasters, including large-scale damage to infrastructure, accelerating tipping points, and a huge loss of life. Our food systems and supply chains are also at risk. Despite the threats, we must strive to create the changes at every level of society and within our communities. Thanks for supporting this channel. I am in the midst of finishing a large project which has caused a delay in publishing interviews, and this should soon be remedied. Thank you. Paul and Hayley, thank you very much for taking the time to speak to me. We want to discuss your new paper, a new conceptual model for understanding and predicting life-threatening rainfall extremes. Can you start by describing the characteristics of the type of life-threatening rainfall extremes that you've been analysing? And for example, do they compare in any way to the Central Europe flooding we've seen very recently?
Just to introduce myself, I'm the Chief Meteorologist at the Met Office and visiting Professor at Newcastle University with Hayley. And I come from the field of meteorology and forecasting. And then that bridge of knowledge to climate is where I work really closely with Hayley, who's Hayley's expertise in climate impacts and extremes. And it's through that dialogue and discussion that we were trying to unpack what is really going on in terms of these really torrential downpours that we've been recently observing, and the consequential impacts of that. It's interesting, when I set up the Flood Forecasting Centre with my colleagues in the Environment Agency, as soon as we created the Flood Forecasting Centre, we found that 2-3 people lost their lives at night, and we didn't have any warnings out. And I wanted to know why. And what we found is these really powerful storms, these extreme rainfall events that lead to these flash floods. And they got swept off the road into a stream. And that started the journey with Hayley about what is causing these extremes. Is there something we haven't observed before? And if we haven't observed it, could we predict it? So that's where that story comes about.
The type of extremes we've been really thinking about are these very localised in general, extreme downpours that cause flash floods, particularly in urban areas where obviously the water has nowhere to go and quickly runs off and aggregates and can't escape to rivers. So it becomes very rapid moving, quite fast, sweeps people off their feet. These sort of processes, though, are also important. The sort of processes we found and we describe in this conceptual model are also important in the type of event we just saw in Central Europe. They're not the driver of that event, so it's much bigger, large-scale cut-off low that really stagnated over that region for a very long time and dropped significant amounts of rainfall, 400 millimetres of rainfall in some parts, huge amounts of rainfall over Austria, Poland and the Czech Republic. But they also have these embedded, very heavy convective bursts within them as well, these systems. So our conceptual model can also be used to describe parts of these larger systems as well that actually produce these downbursts.
When you were watching the Central European flood, it seemed like we did have some notice that it was going to be hitting them quite bad. Would you say that was handled in a good way, as good as it could be, or because lives were lost still, is there a way to make that sort of more resilient or to reduce the life lost?
Broadly speaking, it was very well predicted. So we did have advance notification of this event. The Meteorological, Hydro and Meteorological Services did give advance notification of a threat. And the overall rainfall amounts was pretty good. The difficult bit was you get these localized downpours, which are really difficult to predict because they are very small. And if they just miss the catchment just by a few miles, it can make a huge difference to the consequential impacts on flooding. So that still remains a challenge, but broadly speaking, it was pretty good. I would say that one of the biggest challenges is how then we communicate that so we get the right action on the ground. So we might have the best science, the best warning services, but if no one takes and heeds those actions and that advice, then we're still going to have problems of people being at risk of those damaging flash flood events. And we need to find ways of protecting the public from that harm by providing better advice and guidance and empowering people to take the right action. I think that's really one of the biggest issues that we're facing at the moment.
It's in the introduction of the paper that there were times when the amount of rainfall coming down was exceeding what was in the atmosphere. How does that kind of thing occur?
So if you want to get as much water out of the atmosphere as you possibly can, the first thing you need to do is to feed the atmosphere as much moisture and warmth as you possibly can from outside. And then once you've got that moisture trapped into the atmosphere, you then want to squeeze it like a sponge so tight that you squeeze every ounce of water from that system. So that's one aspect of it. The second aspect is that you don't want all that water to kill the warmth that's feeding it. So you want to have mechanisms where you squeeze that amount of water out, but it falls away from the moisture and the warmth that's feeding it. So you get that aspect of sustainability. The other critical thing you need in a situation which is really damaging is how long does that system last over one particular location? Because you have one system like that, followed by another one, followed by another one, each dumping huge amounts of water in the same location. Then obviously you have a recipe of particularly damaging flash floods. So the three factors is the ingredients that's come into it, the ability to squeeze that moisture as much out of the atmosphere as you possibly can, and then the duration.
Okay, and does the duration also relate to, I think you mentioned in the paper that they can stick in one place and that can really sort of amplify the damage caused. And that reminded me of interviews, I think, with Jennifer Francis in the US, where she was talking about more on the jet stream. I know this is much more localized, but she was talking about the jet stream sticking. Are these similar, related in any way?
Absolutely. They're very much related to changes that we're seeing in the jet stream, and particularly the effect of Arctic amplification on the strength of the jet. In the summer months, in that warm season in the Northern Hemisphere, the jet is weakening because of this increased heating at the poles and this reduction in the temperature gradient between the equator and the poles that drives the jet stream. It's becoming weaker and it's enabling it to basically become more meandering. And that is what caused or was a contributor to the German floods in 2021, but also the recent Central European floods that we've just seen in Austria and Poland. And also Storm Daniel as well. At a similar time last year, in September last year, the devastating storm that hit Greece and then obviously became a Mediterranean hurricane, a Medicane, and hit Libya and caused that absolute devastation in Libya. So all of these types of events are connected. These cut-off low events they become cut off from the jet stream. They appear to be becoming more frequent with warmer temperatures. These systems themselves are also including more of these sort of embedded extreme rainfall events as well that cause these extreme downpours.
You've just said that they are becoming more extreme, and you've just cited Greece, Germany, the Medicane in Libya. I mean, these are absolutely catastrophic events. And anyone, you can pretty much go and talk to anyone and they will talk about the increased intensity of the rain. Where does this kind of end, considering our emissions are they're not going down very fast or at all? Where do we go with this? What's our sort of threshold of resilience if we have it? Is that anything that you consider?
It's really tricky, isn't it? So, I mean, I think one thing that the public don't realise is, quite honestly, this is as good as it's going to get. It's not going to suddenly go back to 20 years ago. The atmosphere's angry. It's got lots of energy. All extreme rainfall events are being intensified by the warmer atmosphere. And, the warming we've already experienced. And, we've been more than 1.5 degrees warmer than pre-industrial times for a whole year now. So if we're not at that 1.5 degree a warming limit, then we're pretty close, right? So we're living in a significantly changed climate, and we're seeing more and more of these very large scale extreme floods and extreme rainfall events causing these floods, as well as, quite honestly, record-breaking heat waves and all sorts of other things happening around the world. And I think we can expect more of these. And one of the sort of difficulties with all of this is that climate models and the things that, these very sophisticated physics-based models that we use to actually predict the future and to project what might happen with additional increases in greenhouse gases, they don't simulate these changes to the jet stream and this weakening and these more meandering systems that really do seem to be causing these very large extremes. And part of that, we think is the lack of connection to the tropical convection. But there's all sorts of other reasons that they don't produce these systems very well. And that's a problem, because actually we can't then say very much or enough about what might happen. So we have these projections that rainfall events will increase, and we know that's true, right? But by how much is uncertain, but it certainly seems to be changing in the real world extremely rapidly.
What's interesting from my experience, I've been a chief forecaster for nearly 30 years now. And one thing that's really taken me by surprise is the oceans, is how warm the oceans have really got to. And we've seen that in the North Atlantic, right? This summer we've just had. And also, talking to my colleagues in the National Hurricane Center as well, is how these hurricanes suddenly spin up very, very quickly as they come in towards the coast. In the previous days, they used to sort of die a little bit, but now they're actually amplifying as they come in coastline. So the whole role of the ocean and the atmosphere and the coupling between that, there's still so much to learn, because we're only starting to unravel the consequences of climate change right now. So we're starting to see things we perhaps never seen before, of which is our paper, which describes these unusual phenomena with these sub-hourly rainfall extremes. But there's other phenomena that's starting to pop up now in a warming climate that we're only starting to observe and starting to get a head around.
The hot ocean is becoming a big feeder of these storms. Is that correct?
Yeah, so the warmer oceans, that the Mediterranean hurricane, there have been studies looking at the role of the very warm Mediterranean temperatures. That would not have occurred without that additional warming from climate change. So that event would have, as Paul says, it would have fizzled out and it would not have become a Mediterranean and hit Libya. There's the rapid intensification of storms we've seen, like Storm Kieran over the UK last year. Very rapid intensification of an extratropical cyclone, a low pressure system that then caused a huge amount of wind and rain over the UK. And then we've seen rapid intensification of tropical cyclones and hurricanes as well in the last few years. And the forecast models can't predict these rapid intensifications because there's something that we haven't seen before. I suppose we understand the mechanisms to a certain extent, but it's then producing these new models like the one we've developed for these very intense sub-hourly rainfall extremes to actually improve the forecasts of these events and make sure that we actually do save lives.
In Bangladesh, I interviewed scientists there. They said that the early warning systems have had a dramatic life-saving impact, and people, they know how to respond when these things come in. How does yours fit into this?
So I was the lead author from the impact-based warnings and forecasting that is part of the United Nations Warnings for All program. So you've probably seen in Bangladesh, they are probably using the same kind of tool, the matrix and the colors that go with that. These tools and these services really do the job, as you just described, has saved many thousands of lives. I think when you're starting to get these really intense extremes, that the speed at which they spin up and the speed at which it really impacts the vulnerable, we may need to sort of revisit how do we target that information to the right people, and how do we respond to these things that for some have never seen before. This term unprecedented. You've heard when you speak to people who have experienced these type of events, I've never seen anything like this in my living memory. So I think there's a piece about, with a changing climate, what could we expect? What do we need to do? When it's really bad, please tell us it's going to be really bad. And how do you communicate that? That is going to be the next challenge, I think, because from a science perspective, we're starting to unravel the secrets of what's going on that produces the extremes. But if that's locked up in research papers and it doesn't get into the hands of people who can take action, then it renders us and our research just a piece of paper. So that's the next big thing, is working with communities, not for communities, actually making that translation from science into action. That's going to be the next push.
But do you think that could get down to a level where people would have something on their phone, for example, that would send a warning? How would you communicate with people? Is it that level that we're thinking of?
There's many options, but one of them is the emergency alert services, which we have adopted here in the UK, where the very point you just mentioned, you do get targeted mobile messages. No doubt that will be increasingly prevalent as we go forward. It's the personalization, I think, as well, is quite critical, and how you communicate and the actions that you need to take, the advice that goes with that warning is just as important as the warning itself.
I think there's also some really interesting work going on in the artificial intelligence field, and particularly notable, there's other organizations that are doing this, but Google are doing some really interesting work, and they've recently released fire. You can actually get on your Google Maps now, you can actually see where there are fires ongoing, and there's plans to actually implement where there are floods as well. And the idea is that you can use these type of systems in real time. You can get notifications and warnings to your phone about where these things might be. Some of this stuff isn't implemented yet, but I think it's really quite exciting to see these type of systems being developed. And these are global systems as well. They're not, local to the UK. Global systems. I think what they don't have at the moment is necessarily the best weather forecast information, perhaps. And so collaborating with scientists and actually starting to try and develop some of these systems together. So using satellite data and image, they've got access to some of the best remote sense data sets, and then marrying this with much better forecasts and conceptual models for those will actually be really, really valuable for society.
That's kind of the data side, and that is pretty amazing if you could get warnings when you maybe move into an area where there's a high risk of fire or flooding or whatever. Paul, you mentioned at the beginning about infrastructure, and obviously we're not resilient in many cases to the world we're just arriving into. How does this, have you had any, I don't know if it's a policy feedback or anything like that, of how we marry that sort of resilience on the ground with what you're doing in terms of alert systems, etc.?
That's a really good question, Nick. I mean, it's a system of systems, right? It's systemic risks, and how does that risk cascade through is something which is an ongoing piece of research. And Nick, the whole compound cascading impacts, right? A single hazard in itself perhaps doesn't lead us as much damage than a compound. I mean, there's research that's done by Chris Wright at Strathclyde, who's leading on this piece of work and exploring, what is the consequences of these compound natures on infrastructure, critical infrastructure like energy, water, food security, energy security, global trade. There's a whole wealth of research that needs to be targeted and linking with me and Hayley's work. That probably is the way we could also look at how we manage future climate change and systemic risks going forward.
At Newcastle University, we do a lot of work with different infrastructure operators across the UK. We lead a big hub for transport called DARE at the moment. So we're thinking about how do we decarbonise the transport system in the UK, working with the Department for Transport, but also how do we actually make it more resilient? So our infrastructure is not resilient, and you can see that from looking just at the past few days, actually, in terms of the number of flood events in the UK, the railways and roads that have been affected, energy systems get affected. We're working with energy operators as well on separate projects. We need to really understand, I suppose, the potential for these very large events. We're not going to design our infrastructure to be resilient to all events. I suppose that's the issue. And you can see that in places like Poland, right? They've got dams burst that are designed to really high standards. In the UK, a dam like that is designed to a 1 in 1,000 year rainfall event. But these are the sort of events we're now seeing, these really large systems that sit over a country for a very, very long time, produce huge amounts of rainfall. They have 2/3 of the annual rainfall in 3 or 4 days. If that happened in the UK, you'd be talking about getting 500 millimetres of rainfall in the Midlands. That's a lot over 3 or 4 days. That would cause devastating flooding. It would cause dams to fail. There's key things we need to think about in terms of both the early warning systems and the disaster response, actually, but all the way through to which systems can you make resilient and how do you make those systems more resilient? It's something we talk about in engineering. It's really this idea of failing safely, right? So some systems are going to fail, but the idea is that you provide life safety as much as possible with those systems. They do this in earthquake engineering, right? So that basically a building fails, but you're providing life safety up to that point. So it fails in a safer way than just literally collapsing. And I think we need to be thinking about making infrastructure systems, not just in the UK, but in the world, safer in this way, so that we provide that life safety for people as much as we can.
Paul mentioned unprecedented, that word that gets sort of used quite a lot these days. And you just said, if what happened in Poland happened in the UK, is that if actually a when?
Yes, it could happen here. That's clear. And in my opinion, we should be thinking very carefully through these sort of situations with a number of infrastructure operators, with emergency responders, with people like Paul at the Met Office and emergency warnings, and thinking about how we would actually respond to one of these sort of situations should it occur, because at some point there will be a major flood event in the UK. There's no physical reason why these type of events can't happen in the UK, but we've been lucky so far. So yeah, there needs to be much more thought to these sort of plausible extremes that could happen and how would we actually manage them.
It's quite easy to go down a sort of worry rabbit hole, but when you start talking to the kind of work that you guys are doing, it's like, well, actually, there is a way through it, but we do have to address these bigger challenges of the emissions and all the rest of it. Is there a story in this that is actually quite positive, do you think, with what we're learning and starting to understand these systems better, etc.?
I think the positive thing is that we understand some of the processes perhaps a bit better, and we think we can produce better early warning systems. I think there's also a lot of work that we can do on better communication of those warnings. I think that we really need to reduce greenhouse gas emissions as fast as we can, because climate is changing really rapidly, and that's really not a positive thing, right? We're seeing huge numbers of unprecedented heat waves, unprecedented rainfall events, unprecedented flooding, unprecedented giant hail and tornadoes. It's getting wild out there, and it's going to get wilder. So, there's positive things we can do as a society to try and plan these types of events, but quite honestly, we really do need to put the brake on emissions as soon as possible.
I would echo Hayley there. I just understanding the process just gives us a fighting chance to give advance notification, right? That something bad is going to happen. But also, I wonder whether it's a bit of drawing people together, transdisciplinary working in partnerships. Everybody's having the same concerns and issues. We only can do this if we work collaboratively together. And in that, I mean business, industry, private, big technical companies, as we just mentioned, also the public sector. It has to be a call to arms, working together to unpack this and getting the best that we've got on this, so we can at least try and mitigate some of the potential damages, right, of climate change and extremes.
Okay, so you see the collaborative effort right across the board is a key accelerator of resilience overall. It's
a must. It's a must. We can't do without that.
Okay, and my original point is there a positive story? There is really the 10 years ago, all of this was in the future. The big impacts we were more or less anticipating. Now they're all around us. That if people think, well, we've got a fighting chance, but we do have to bring the emissions thing becomes more tangible in a way, I think, as more people are engaging with this subject.
And also the next generation, because me and Hayley spend a lot of time, with students and the next generation coming through, and that is important. That whole, I hate the word, but education and learning together, I think that's critical, because this generation will then go to the older generation and say, well, look, how can we work together? It's a generation piece as well as a collaborative across partnerships. we talk about collaboration, but there is a massive collaboration for the global through the United Nations, through WMO, through other bodies like the World Bank, because it has to be a global endeavor if we're going to fix this emerging issue.
It's been really interesting to speak to you. So thank you.
Absolute pleasure.
Thank you.
Thanks, Nick.
Please consider subscribing to ClimateGenn, and if you haven't already, order a copy of Nick's book, Cop Out, today.